process is that you need to take each of these sections. These will change to completed as you make progress and finish each topic. If at any time during this training you feel that you are ready to take the certification exam, you can click the certification assessment link that appears at the bottom of the topic's column. You should also know that from anywhere in this course you can access the screen by clicking the progress report button that appears here. Now, are you ready to get started? Just click on the next button and your first topic will launch automatically.
This is the first of several modules presenting Foundations training on the B-Block system technology. Upon completion of this training, you'll be able to distinguish between the traditional, reference architecture, and converged infrastructure data center models. You'll be able to describe the advantages of the VCE B-Block system converged infrastructure over the other data center models, and describe the purpose of each of the core B-Block system technologies, which include compute, storage, network, virtualization, and management. In this first section, we'll discuss the technology models found on the enterprise data centers today, including the benefits and disadvantages of each. In addition, we'll talk about the current trends in the use of data center technology.
In the past, information technology organizations designed, purchased, built, tested, and implemented their own systems using components acquired from multiple vendors. This process required a complex procurement process for the IT department to ensure that all parts were ordered correctly and were received in time for assembly. It also meant that IT was taking on a difficult-to-manage maintenance and update process. Significant planning to ensure systems availability was needed for the smallest of new upgrades to products or features. And it nearly always required the management of multiple vendors to coordinate support when anything went wrong. The traditional IT organization tends to align with component types resembling a set of silos. Each silo has a primary focus on its own resources and operations, with limited visibility into or interest in other silos. One group is responsible for applications, another for compute, another for networking, and so on. The result, according to analysts, is that the majority of enterprises' IT budget is spent on maintaining operations rather than investing in new business capability. The evolution of IT is transitioning customers to the next generation in data centers featuring the VCE B-Block converged infrastructure. Click through each tab on the left to continue. Data centers and the policies and procedures they operate under have existed for many years. The traditional data center holds tightly to many out-of-date practices due to habit and sometimes fear of change. They lack the agility and efficiency that a state-of-the-art data center provides. As a result, the typical IT strategy is to deploy one dedicated server for each application. It is common to find hardware dedicated to one business-critical application, with departments of IT staff dedicated to the operations and maintenance of these unique and specialized platforms. Implementation of IT projects are slowed by policies and procedures that can confound project teams with guidelines and workflows that contradict rules followed by other project teams in the same data center. The result is too much spent to purchase and maintain compute, storage, and network components, most of which are significantly underutilized. In addition, traditional data center projects frequently lack cohesive standards to help integrate various projects. As a result, the IT department acquires equipment from various vendors and becomes responsible for designing infrastructure, assuring interoperability with the various components, and validating and implementing all software, hardware, and firmware upgrades over the system's life. In the traditional data center, maintenance and troubleshooting require communicating with each separate vendor to identify problems and potential problems resulting from the interaction of the various components. A reference architecture brings a template approach to the traditional data center. The reference architecture is essentially a document detailing a successful implementation of a system involving specific hardware and software configurations. One of the downsides of using reference architectures is they are not necessarily updated regularly to accommodate hardware, software, firmware, and other updates. Buyers take on the task of architecting, configuring, and testing systems using components from several vendors that may have been updated or become unavailable since the reference architecture document was produced. This leaves significant work determining how to make the new configuration work properly. And in many IT organizations, multiple reference architecture installations may result, all with different architectures, equipment, and specialized skills to operate and maintain. As a result, similar to the traditional data center model, low equipment utilization rates and significant resources dedicated to IT maintenance tasks is seen. There is a variation of the reference architecture often referred to as a single stack, where a vendor creates a reference architecture made of exclusively components with a single brand, either manufactured by or OEM'd to a single vendor. These infrastructures are always a compromise since they exclude the best-of-breed technologies from EMC, Cisco, and VMware, and are still assembled by the customer. The primary benefit of single stacks is that they involve fewer vendors when support is needed. The VCE V-block is the first converged infrastructure. Converged infrastructures are pre-engineered, pre-configured, pre-assembled, and pre-tested with all components delivered as a single product. In effect, it is a data center in a box. V-block system converged infrastructure consists of the industry-leading technologies from Cisco, EMC, and VMware. They're assembled, tested, and packaged in a factory to meet buyers' specific needs. All support for the entire V-block system is provided by one source, VCE. When needed, VCE support consults experts from Cisco, EMC, and VMware to resolve unusual cases. In addition, to take the guesswork out of updates and upgrades, VCE publishes a synchronized support matrix to facilitate reliable transitioning from older firmware and patch levels to the latest validated versions. The result for customers is a single system with defined performance capabilities on which multiple applications using any x86 operating system can operate. And all support for the system and all of its components comes from one source. Before V-block systems and converged infrastructure, most business applications ran on dedicated hardware and operating systems. Using the traditional data center or reference architecture models, this one application, one server approach led to significant investment in technology that provided little flexibility while at the same time requiring extensive resources, including budget, floor space, electricity, cooling, and staff. There were little or no standards, many vendors, underutilized systems, and the need for specialized skills to manage and maintain each individual system. Operating systems and business-critical applications can run on a single V-block. This one product contains the compute, network, storage, and virtualization needed to accommodate nearly any conceivable IT demand. The elimination of the one application, one server methodology increases resource efficiencies. Applications running on distinct operating systems can be loaded and operated from a single V-block system. And because V-block systems are completely supported by a single vendor, management, maintenance, and support needs are all addressed by VCE. Customers have three options. They can do all the work themselves, which includes designing the system, sourcing components from multiple vendors, ordering parts, inventorying the parts as they arrive, unpacking and discarding packaging, building the system, testing the system, and then implementing the solution. Or they can purchase and build using a reference architecture design, which eliminates some design tasks, but still requires significant work sourcing, purchasing, inventorying, unpacking, building, and testing. Or they can purchase a V-block system converged infrastructure, which requires ordering, taking delivery, then placing workloads onto the system. Customers choose the V-block system because they can order a single product that will be delivered from a factory to the data center floor in 30 to 45 days. Compared to the traditional data center, V-block systems provide reduced complexity and risk. Each VBlock system configuration is pre-engineered with specific components, component assembly locations, and component interconnection configurations. This means that all aspects of the process of building, delivering, and implementing a VBlock system is simple, consistent, predictable, and repeatable.
Now that you've learned a little about the traditional data center, reference architecture, and converged infrastructure models, let's explore the VBlock system's converged infrastructure in more detail.
VCE's history began on November 3, 2009, when the leaders of three of the IT industry's most successful companies, EMC, Cisco, and VMware, gathered to announce an unprecedented collaborative effort designed to help customers increase business agility and lower costs through pervasive data center virtualization and a transition to cloud computing. VCE provides an optimized information technology system that delivers secure and predictable performance. We speed time to deployment of infrastructure and then optimize ongoing operations through system lifecycle assurance. Let's step through the VCE value stack to better understand the VCE differentiators. VCE designs and delivers VBlock systems, which seamlessly integrate leading compute, network, and storage technologies. Through intelligent discovery, awareness, and automation, VBlock systems provide the highest levels of virtualization and application performance. Each VBlock system is engineered, integrated, and tested in factory so that it can be delivered 30 to 45 days from order. It will be operational on site within a few days of delivery. To help deliver required service level agreements, data protection and workload mobility solutions are integrated and factory validated. A comprehensive range of backup, recovery, and workload mobility solutions are already tested and supported by VCE before delivery. But VBlock systems are not just delivered as a converged infrastructure, they're also managed that way. VCE's unique approach to intelligent automation provides dynamic awareness of all system resources, correlates events, and eliminates the need for traditional, manually intensive integration of system resources. VCE's lifecycle system assurance means that customers don't have to worry about managing patches and updates from multiple vendors, which can be very resource intensive. VCE integrates patches and performs regression analysis to ensure component interoperability over time. This further reduces costs and, more importantly, reduces business risk. And VCE works with software vendors to assure customers that applications will be configured according to best practices to reliably deliver the optimum application performance. All of this means faster time to business, the performance and availability customers need at lower cost and with reduced risk to the business. In fact, when IDC interviewed VCE customers to compare operations before and after the VBlock system's deployment, this is what they found. First, the deployment of VBlock systems occurs 4 times faster than other converged infrastructure alternatives. VBlock systems are typically delivered 30 to 45 days after being ordered and arrive as a single product. Some minor reconnection of components is performed to take the VBlock from a ready-to-ship state to a ready-to-run state. Then the VBlock is plugged into the power supply and the buyer's network, and it's ready to install production workloads. Second, after implementation, VBlock systems produce a reduction in system downtime by 96% over other data center model alternatives. Greater availability translates into less downtime and more productive business operations. Because it consolidates applications into a single solution and simplifies management and maintenance, customers who purchase and implement VBlock systems typically find that 79% less staff effort is needed compared to equivalent systems in a traditional data center. And finally, due in great part to the benefits of faster deployment time, better availability, and lower staff time, VBlock systems offer a cost savings of 50% compared to other data center alternatives. Companies can transform IT operations to achieve phenomenal results. IT staff can move up from a silo view focused primarily on compute, storage, network, or virtualization wide view, where they can add more value and contribute greater innovation. V-block systems from VCE represent the next evolution in IT, one that unleashes simplicity by delivering the extraordinary efficiency and business agility of virtualization and cloud computing, seamlessly integrating best-in-class compute, network, and storage technologies from industry leaders Cisco, EMC, and VMware. V-block systems provide dynamic pools of resources that can be intelligently provisioned and managed to address changing demands and fleeting business opportunities. This expansive V-block systems portfolio is built on a single, highly secure, standardized, market-leading infrastructure. Pre-integrated, tested, and validated, the systems can be quickly deployed, easily distributed, and counted on to increase the predictability and timeliness of IT projects for solution providers and end users alike. The broad line of available V-block systems allows VCE to provide the best solution for a wide variety of organization sizes in a wide variety of industries. Later in this training, you will learn about these V-block systems in much more detail. To explore more about the advantages of V-block system converged infrastructure, take a moment and review this scenario that illustrates the process of acquiring a new system using the traditional data center model versus the acquisition of a new V-block system. In this scenario, the organization is a mid-sized but growing data center considering transitioning from a traditional data center model to converged infrastructure. Click on and review the content of each box to the left to learn more about their alternatives. Remember that in the traditional data center, the one application on one server model dominates. Each system is pretty much custom built for the application being deployed. Few, if any, standards are used, and the system is procured piece by piece from multiple vendors. Let's discuss the tasks needed to complete the project of building a new system in the traditional data center model. First, sizing of the application is completed to determine upfront what the system needs are to run the new application. Once sizing is done, the new system is designed, which includes defining all of the components, connections, boxes, power requirements, floor space requirements, etc. Next, with the design in hand, procurement begins. All components and parts are purchased separately from multiple vendors and arrive separately at the company's receiving dock. Over time, as shipments are received, an inventory of all of the needed equipment is stored until all parts have been received. Next, all of the components are unpacked and packaging is discarded. Now assembly of the new system can begin. Assembly can be a difficult and tedious process as parts are located, assembled, and sometimes need to be replaced before assembly is complete. Once assembled, the system is tested to ensure the hardware and software work as designed and the application is finally loaded and tested. Then, after all the final adjustments and modifications are complete, the system is ready to be launched. In contrast, the process of purchasing a new V-block system is much less labor-intensive for the IT department. First, like with the traditional data center model, the application is sized. Next, the appropriate V-block system is ordered. In this scenario, with the customer a mid-sized and growing data center, a V-block system 200 may be a good fit. Then the V-block system arrives at the customer shipping dock, pre-assembled, pre-tested, and ready to connect to power in the customer's network. Applications are then loaded, and the system is launched. Now let's examine the differences between these two processes. First, the V-block system can be delivered between 30 and 45 days from the day it is ordered. As you learned earlier, it arrives at the customer's site a pre-assembled product. In contrast, the process of building a system using the traditional data center model can be much more complex. The process, if well and efficiently managed, could be completed in 3 months, but it could take much longer. At the end of both of these processes, the company has a new functioning system running the needed application. However, there are some other differences to consider. First, while the single application has been launched and running on the new V-block system, the next time the customer has a new application to launch, it can be installed on the same V-block. After determining the application requirements, the application can either be installed on the V-block system as is, or the VBlock can be quickly and predictably expanded to support the additional workload. Also, as you continue to learn in this training, operating and maintaining a VBlock system converged infrastructure saves significant time, staff resources, and money compared to the traditional data center model. As the scenario demonstrates, the VBlock systems provide a much faster time to value than the traditional data center approach.
With a basic understanding of data center technology models and the VBlock system converged infrastructure, it's time to begin learning about the core technologies that constitute the VBlock systems.
The logical technologies of a VBlock system are compute, network, storage, virtualization, and management. Before diving into each of these in detail, let's spend the next few minutes talking about the role that each of these play in the functioning of a VBlock system. The VBlock system compute is the part of the system that runs the operating systems, such as Linux or Windows. In business applications, such as email servers, customer order and data processing systems, and enterprise management software. VBlock system compute is provided by Cisco's Unified Computing System, referred to as UCS, which includes blade servers or rack mount servers, as well as other components. Later in this course, we will discuss VBlock system platforms in which each of these UCS form factors is utilized. The UCS blade servers are inserted into a chassis that can contain several blade servers. The UCS blade chassis include fabric extenders, which connect to the fabric interconnects that provide connectivity to the VBlock system's storage and networks. Rack mount servers alternatively install directly into VBlock racks, not a chassis, and do not require fabric extenders or interconnects. You'll learn more about these components and configurations later in this training. VBlock Systems network technology provides connectivity for communications between all components inside the VBlock system and between the VBlock system and the organization's core network. VBlock Systems networking can be logically divided into two parts: an Ethernet local area network, or LAN, and a storage area network, often referred to as a SAN. You will learn more about these during the rest of this training, but for now, understand that a LAN is used to communicate and move data between devices such as compute servers, PCs, laptops, tablets, cell phones, and any other device on a network. A SAN is a specialized network that handles communications between a storage device and any device allowed to access it. VBlock systems utilize a combination of Cisco Ethernet switches in LAN networks, fiber channel switches for SAN networks, and unified switches to support both LAN and SAN on a single switch. VBlock systems also use a Cisco virtual switch, which provides LAN switching on a virtual network. We'll discuss all of these in much greater detail later. Storage systems provide a safe and secure place to store data in the VBlock systems. The core components of storage includes storage drives, disk array enclosures, and data processors. You'll learn more about all of these later, but feel free to click on the links for a brief description. All VBlock systems include storage technology from the industry leader EMC. The EMC product family utilized in each VBlock system depends on the model purchased. VBlock systems can include EMC's VNXE, VNX, or VMAX storage products. Each storage product family has different capabilities, most notably their storage capacity and the number of input and output operations per second, or IOPS, the system can perform. The greater the IOPS number, the greater the number of operations a storage product can complete in a unit of time. The VBlock system virtualization leverages VMware's virtualization platform, vSphere. Virtualization can be a difficult concept to understand, and we'll spend more time learning about it later in this training. But for now, understand that virtualization provides the capability to load and run more than one operating system and business application on the same physical equipment. It allows for the assignment of physical computer resources such as memory, CPU, and storage space to individual virtual machines, or VMs. In doing so, expenses can be reduced by consolidating enterprise business applications onto fewer servers and storage devices, and by creating rules that automate how systems are managed. Management is enhanced by VCE's Vision Intelligent Operations software, which continually monitors the vBlock for proper configuration and provides a standard management platform across all vBlock models. Each of the components in the vBlock retain their original management interfaces and capabilities, but Vision Intelligent Operations simplifies monitoring by providing a single API, MID, and syslog. The Unified Infrastructure Manager Provisioning Center, UIMP, is also available for most vBlock models, and it automates the error-prone and tedious tasks that are usually required to provision an infrastructure, such as making storage available, zoning fabrics, and creating service profiles for Cisco UCS. These are all things you'll learn more about later. The vBlock system is a completely integrated cloud infrastructure offering that includes compute, storage, network, and virtualization products. The vBlock system components are produced by the members of the coalition formed by EMC, VMware, Cisco, and Intel. vBlock systems enable organizations to build virtualized data centers and cloud infrastructures. They are pre-architected, pre-configured, pre-tested, and have defined performance and availability attributes. Rather than customers buying and assembling individual cloud infrastructure components, vBlock systems provide a validated cloud infrastructure solution and are factory-ready for deployment and production. This step saves significant cost and deployment time. In comparison to other data center approaches, vBlock systems produce a very fast time to value.